Here are the answers for the multiple choice to Monday's lab. The value or values of x that satisfy this equation are which of the following? So if I were you, definitely an option is to just plug these numbers in for x and see what works and what does not work. So if we plug in the number 5, we could do it like a check. We would have 5 squared minus 4 times 5 minus 5. The left side comes out to 0. And if I plug it into the right side, I also get 0. So I know that 5 works, which eliminates answer choice 2. Now I could try the 7. Plugging it in, 7 squared minus 4 times 7 minus 5, I get 4. And if I plug it in, the 7 into the right, I also get 4. So I know 7 works, so answer choice 1 is out. My answer has to contain both a 5 and a 7. So now I'll check the 3. 3 squared minus 4 times 3 minus 5. If I plug that 3 into the right, that definitely does not match, so 3 does not work, so it is answer choice 3. We should know how to do this by hand also. Step 1 of a radical equation is to isolate the radical, which it is. So step 2, square both sides. Squaring the radical, the x squared minus 4x minus 5 comes out. Squaring the 2x minus 10, we write it twice and double distribute. Multiplying it out, you get 4x squared minus 20x minus 20x plus 100, which is 4x squared minus 40x plus 100. Because I have something squared, I'm going to set it equal to 0. So subtract the x squared over, add the 4x, add the 5, and I get 3x squared minus 36x plus 105. I can take out the 3 as a GCF, and then factor the trinomial with the AM method. And then last, set each factor equal to 0. When I go to set the 3 equal to 0, that does not make sense, so the 3 rejects. So 7 and 5, always check your answers to a radical equation by plugging them back in, which is exactly what we do when we try plugging in the answers anyway, which is why if I were you for multiple choice, I would do it the way I initially did it, where I just plug the number straight in. Short answer, you have to know how to do it by hand, but multiple choice, I would definitely plug the numbers in. Question 8. Stephanie found that the number of white-winged crossbills in an area can be represented by the formula C equals 550 times 1.08 to the t power, where t represents the number of years since 2010. Which equation correctly represents the number of white-winged crossbills in terms of the monthly rate of population growth? If they are definitely equal, then you could plug into y equals on the calculator, plug the first one that was given to you into y1, and then plug each answer choice into y2 and see which one gives you almost an identical table. It's not going to be perfect, the numbers are rounded, but the one that is correct should give you pretty close to the original. This is where we're changing the exponent. T is currently in years, we want months. The units you're in go in the bottom. The units you want go on top. There are 12 months in 1 year. Years cancels, and now you have the new number that should be getting attached to your exponent. So 12t is my new exponent. There's only one answer choice here that shows a 12t as your exponent, so it is automatically answer choice 2. But the way they got the number for the inside, if they are introducing this 12 on the outside that was not originally there, you should be putting a 1 over 12 on the inside. And when you type 1.08 to the 1/12th power into your calculator, that is where that 1.00643 number comes from. Number 9, the roots of this equation are which of the following? Now, this is multiple choice. 2 of the answer choices are really not nice with radicals and i's in them. So because of that, I would not bother trying to factor. Instead, I would use my quadratic formula, which is on your reference sheet. But before we do that, we have to add the 7 over so that the whole equation is equal to 0. That means that our a would now be positive 3, b is positive 2, and c is positive 7. Your quadratic formula is on your reference sheet, so you do not have to have it memorized. So plugging in negative b plus minus b squared minus 4 times a times c, all over 2 times a. Negative 2 is just negative 2. When you type the inside of the radical into your calculator, without the radical, you get negative 80 for inside. 2 times 3 is 6. Radical negative 80 is negative 16 times 5. So we get negative 2 plus minus 4i radical 5. Now there's only one answer choice with an I in it, so it's automatically answer choice 3. But the way we would get that would be to split it up. We divide both pieces on top by 6 separately. And then negative 2 over 6 simplifies to negative 1/3. 4 over 6 is 2/3. And then the I radical 5 is still there. So that brings us to answer choice 3. Question 10. The average depreciation rate of a new boat is approximately 8% per year. If a new boat is purchased at a price of $75,000, which model is a recursive formula representing the value of the boat n years after it was purchased? Recursive formula, remember, is the one that has to keep building. It's kind of like a ladder that you have to keep climbing. So there should always be 2 parts to it. So that eliminates answer choices 1 and 3. Those are not recursive formulas because it is not a 2-part formula. It's just one big formula. When you write out your recursive formula, the part that has the formula in it, the AN equals, the opposite side should always contain an AN minus 1. That's the way the recursive formula works. That's the notation we use. So this one has to be answer choice 4, not 2, because answer choice 2 has no AN minus 1 notation with it. Question 11. Given that cosine is equal to 7 over 25, where theta is an angle in standard position terminating in quadrant 4, and sine squared plus cosine squared equals 1, what is the value of tan theta? So one option is to do it like the homework question that was on this weekend's homework that you guys looked at last period, where you can set up a triangle and do Pythagorean theorem in SOHCAHTOA. But I'm going to show you how to do this with the Pythagorean identity that's given to you. Cosine is 7 over 25. So I'm going to plug that into the formula that was given. 7 over 25 squared, since cosine is being squared. So on my calculator, 7 over 25 squared. You can keep it as a fraction if you want, or make it a decimal, your call. It's a nice decimal. To get sine by itself, I'm going to subtract it over. Again, you can have it as a fraction. So that gets me sine squared equals 576 over 625. Take the square root. So we get that sine is 24 over 25. We're looking for tangent. Tangent is sine divided by cosine. That would have to be memorized. So taking sine, dividing it by cosine, since they're both over 25, the 25s cancel. And we get 24 over 7. Like I mentioned on the homework that you guys looked at, every trig question ends with ASTC. They said that we were in quadrant 4, where cosine is positive, so that means my tangent answer needs to be negative. So answer choice 2. Like I said, you also could have done Pythagorean, you could have set up a triangle, quadrant 4, setting up your triangle. Cosine is adjacent over hypotenuse. So your adjacent side was the 7, hypotenuse was the 25. Pythagorean theorem to get the opposite side would have gotten you 24. And then for tangent, you could do opposite over adjacent. You get the 24 over 7 again, and you would still end with ASTC to make it negative. Question 12. Anytime you see a radical, like I said, if it's not a radical equation where you are solving for x, you are expected to be doing power over root. This type of topic, power over root, shows up on every Regents exam. So the first x on top is x to the 2/3. Next one, if we don't see a number there, it implies there's a 2. So that is x to the 5/2. The bottom x is to the first, so it becomes x to the 1/6. From there, on top, they are being multiplied. So we add the exponents. Do it right on your calculator. 2/3 plus 5/2. You get x to the 19 over 6 power over x to the 1/6. From there, you're now going to subtract your exponents. You could do it right on the calculator again. You get either 18 over 6 or 3. So answer choice 3. This is another one that you could do the calculator for in y equals if you wanted to. If I plug the original into y1, math gets you all the different kinds of radicals. Radical x to the 5th. And it's over the 6th root of x. and then plug the answer choices in. So if I plug the right one, x cubed, my tables after the error messages, my tables do match. Whereas if I plug in the others, let's say just x for the first one, those tables definitely do not match. Question 13. Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below summarizes the amount of money he plans to save each week. Based on this plan, which expression should he use to determine how much he has saved in n weeks? So if we're looking for how much he saved, we're looking for his total. And we have to X out and go back in. We're looking for Jake's total. Which means we're looking for a sum or a series. This formula is on our reference sheet. You do not have to have it memorized. A1 is the first term, how much he is starting with. So Jake is starting with $2. And we just have to find R. Now the nice thing is you don't even have to find R at this point. You should be able to match up and get the right answer choice. Answer choices 2 and 4 have our exponent as n minus 1 when this formula shows it as just n. So that eliminates 2 and 4. And on top, we definitely should have 2 minus 2 times something to a power, which is not what answer choice 3 shows. So it's answer choice 1. To find R, you can work backwards. If it's geometric, we multiply to go forwards. So going backwards, we're going to divide. And if I take 5 divided by 2, I get my 2.5. That should be in there. You also could have gone with 12.5 divided by 5. That would also get you 2.5. You could do the 31.25 divided by 12.5. That would also get you 2.5. 14. Which expression is equivalent to this? So equivalent means they are exactly the same. So one option, unfortunately you can't go into y equals right now. If you wanted to, you would have to plug a number in for the only y that's there. I would say let's make y a 2. If you plug that in and then plug 2 in for y into all the answer choices, then you can use the y equals button on your calculator. Otherwise, this is a factoring question where they already started it for you. We have two things here. They both have this x to the 4th minus 16 in common. So I can take it out as a GCF. And then left over would be the x to the 6th, y to the 4th, minus 9. From here, both are dots. X to the 4th minus 16 is x squared plus 4, x squared minus 4. And the x to the 6th, y to the 4th minus 9 becomes x cubed y squared. You're cutting the exponents in half. 9 is 3 and 3. And then 1 is a plus and 1 is a minus. So this right now matches answer choice 4. (15) If A is equal to negative 3 plus 5i, B is equal to 4 minus 2i, and C is equal to 1 plus 6i, where I is the imaginary unit, then A minus B times C equals, So plugging all of these in for A, B, and C, we get negative 3 plus 5i minus B, which is 4 minus 2i, times C, which is 1 plus 6i. Hard part, I think, is making sure that you plug those in with parentheses. And then from there, I would type this into my calculator. Let your calculator do the order of operations for you. Make sure if you go to mode that you are in A plus BI mode. Should also be in radian mode. So make sure that you're in A plus BI mode. And then now you can type in negative 3 plus 5i minus 4 minus 2i, 1 plus 6i. And your calculator gives you negative 19 minus 17i, which is answer choice 3.